seventh problem. The ladder shown in figure 7. Here is a ladder which leans on a wall at the end B and rests on the floor at end A. Total length of the ladder is 6 meter. At the center of gravity of the ladder, the weight of the ladder acts. The weight of the ladder is 200 Newton. One more 900 Newton act at C, which is 1 meter from the end B. The inclination is unknown. This is angle alpha. Now, the ladder shown in figure 7 is 6 meter long and is supported by a horizontal floor and vertical wall. The coefficient of friction between floor and the ladder is 0.4. Floor and the ladder is 0.4. Therefore, here this is mu is 0.4. The floor and the ladder is 0.4. And that between the wall and the ladder is 0.2. So, here the frictional force mu, coefficient mu is 0.25. The weight of the ladder is 200 Newton. Here the weight of the ladder is 200 Newton and may be considered as concentrated at G. So, it is acting at G, the center of gravity. The ladder also supports a vertical load of 900 Newton. Here is a 900 Newton which is supported by the ladder at point C, which is at a distance of 1 meter from B. So, this from B, this distance is 1 meter along the ladder. Determine the least value of alpha at which the ladder may be placed without slipping. Determine the reactions at that stage. So, to find reaction N at A, reaction N at B and the angle alpha. Now, we draw the free body diagram for the ladder. We take the ladder. The ladder is at a distance of totally 6 meter. Ladder is 6 meter, but this is divided into 3 meter by 3 meter. Here at the center of gravity, the weight of the ladder is assumed to be acting. Here is the reaction for normal reaction for point A. The movement of the ladder slip like this at the bottom and it slips like this at the top. Therefore, the friction Fa is equal to mu Na. The frictional value is given as 0.4. Therefore, Fa is equal to 0.4 Na. Here is the reaction B. Because the ladder slides down, the frictional value will be Fb up, and it's nothing but Fb is equal to mu Nb, that is 0.25 Nb. Once again, there is 1 meter length. One more load is assumed to be acting. That load is 900 Newton. That load is 900 Newton down. Here is alpha. Here is alpha. So now you have to find Na, Nb and alpha. Applying equilibrium equations, sigma Fy equal to 0 implies Na, okay, Na upward, then Nb upward plus not Nb, Fb upward minus 200 downward and minus 900 downward. This implies Na plus Fb is nothing but 0.25 Nb, which is nothing but 900 plus 200, that is 1100. This is equation 1. Similarly, we apply for sigma Fx equal to 0, we get Fa positive. Again NB negative minus NB negative. That's all. We have the NB towards the left negative, FA towards the right positive equal to 0 implies FA is nothing but 0.4 NA. 0.4 NA 0.4 NA minus NB equal to 0. This implies NB is equal to 0.4 NA. NB is equal to 0.4 NA. Therefore, NA plus 0.25 into NB, that is nothing but 0.4 NA, which is equal to 1100. That is, substituting the value of NB as 0.4 NA in equation 1. Substitute value of NB in 1. We get NA, this is NA plus 0.25 into NB. So 0.25 into NB, that is NB is nothing but 0.4 NA. This implies, we take the NA common, we get 1 plus 0.25 multiplied by 0.4 into NA is equal to 1100. 1100. Therefore NA is equal to 1100 divided by 1 plus 0.25 multiplied by 0.4 is nothing but 1000 Newton. NA is equal to 1000 Newton. Therefore, NB is equal to 0.4 NA. 0.4 NA, which is equal to 0.4 times 1000, implies NB is equal to 400 Newton. Therefore, NA is equal to 1000 Newton and NB is equal to 400 Newton. Now, taking moment at A, this is A and this is B. Taking moment at A, counterclockwise positive, sigma MA equal to 0 implies we can eliminate the forces for which the line of action passes through A. That means we can eliminate this and we can eliminate this, NA and FA. We take this 200 force, therefore it is clockwise, therefore 200 minus multiplied by this distance. Because this is alpha, this is the cos component. So this distance is 3 cos alpha. This distance is 3 cos alpha. Okay. Again minus 900. This 900 multiplied by total distance is 6. You have 1. So therefore this distance is 5. Once again this 5 cos alpha. Again we take this force. This is nothing but NB, and this distance is sin alpha. Total is 6. Therefore this is 6 sin alpha. So this direction is, let us say A is here and we have this point. So therefore we get counterclockwise. So NB counterclockwise positive. So NB multiplied by this distance is 6 sin alpha. Once again we have FB. FB also, this force also leads to counterclockwise. So positive FB multiplied by this distance, the total distance. So this is 6 meter. So this distance is 6 cos alpha horizontal. So 6 cos alpha, which is equal to 0, implies NB is nothing but 400 into 6 sin alpha plus FB. FB is nothing but, we have the FB as 0.25 NB, 0.25 into 400 into 6 cos alpha, which is equal to 200 into 3 cos alpha plus 900 into 5 cos alpha. Once again we take the cos alpha term as cos alpha and sin alpha term together, we get cos alpha as 200 into 3 plus 900 into 5 minus 0.25 into 400 into 6 cos alpha is nothing but 400 into 6 sin alpha. Now we take the cos alpha term one side and the sin alpha term to the other side. Now we calculate 200 multiplied by 3 plus 900 multiplied by 5 minus 0.25 multiplied by 400 multiplied by 6 as one term. So this is nothing but 4500 cos alpha is equal to 2400 sin alpha. This implies tan alpha, that is sin alpha by cos alpha, is equal to 4500 divided by 2400 is nothing but 1.875. Therefore alpha is equal to, tan inverse answer gives 61.927 degree. Summary NA is equal to 1000 Newton, NB is equal to 400 Newton, alpha is equal to 61.927 degree.